Hey, hello, welcome to the show. It's me, John Park. It is time for my workshop show called John Park's Workshop. Hello, everyone, and thanks for stopping by. Thanks for jumping in over on our chats. We've got the YouTube chat happening. Hey, Robert Cochran over there, Dave Odessa, I should say, Beata Graf of Delhagen, Johnny Bergdahl, Carr is Carr, Maroj Vora, hello, thanks for popping in over there on YouTube. Excuse me. A little something in my throat. If you're somewhere else and wondering where the chat is, somewhere other than YouTube, then I'd say go check out our Discord, which is this right here. Go to the adafruit.it/Discord, a little URL shortener action there. Look for the live broadcast chat channel because that's where people are hanging out. Hi, Paul Cutler is over there. Starman, Johnny Bergdahl is there as well. Thin Man, hello. Hey, John Nodge. Thanks for popping by, and let's get on with the show. Well, what's happening here today? I've got some cool Apple II Plus related stuff happening a little later. I have a coupon code for you if you want to go save some money in the Adafruit shop. I've got a recap of the product pick of the week from Tuesday, and I have a pretty snazzy, I think, CircuitPython Parsec for you to go over as we dive deeper into this memory display game sort of thing that I have realized I'm making now. Excuse me. I have no idea if covering that lav mic helps not have me clear my throat at you. You know what I need is a good mute button, like a press to mute release. I don't have that. Let's see. No, I'm feeling great. Thank you, Robert Cochran. I just ate lunch. I just wolfed down lunch, and I think it's just, you know, front of the system digestion going on. I'm going to drink some water. Hey, Carr says over in the YouTube chat, I'm new to this channel. It's my first stream I'm watching, and I'm here because I love Arduino and coding. Very cool. Oh, hey, you know what? I think I'll do a... Speaking of Arduino, I'll do a little bit of a recap of the Learn guide I just did, which is in Arduino, so that might be of interest. So someone remind me. You know what? I'm going to open up a tab for that right now. Nope, not that way. Hold on. Learn.adafruit.com. All right, we'll check that out. Okay, so as promised, I've got a coupon code for you. If you want to go to adafruit.com, that's the store, head on over there. Throw some things in your cart and save 10%, then you want to use this coupon code because it is good until midnight tonight, so you got some time to make some choices, some decisions. Fritter, F-R-I-T-T-E-R, Fritter, however you want to pronounce it. That'll save you 10% off in the shop, and when I say the shop, I'm talking about not that, this right here. This is, move that over there. This is the Adafruit store, and you can see we got some new products, a bunch of new e-ink screens coming out, some sensors, different pressure sensors here. You can click right on this View All New Products link to see what's new. Some of it's so new that it's not in stock yet. And by the way, we never take rain checks. We never take your money and then say we're going to send something later. So we only let you buy stuff that we have in stock. We don't want to get involved with all that hoo-ha. So if it's something that's in stock, you can save 10% off on it today using the coupon code FRITTER. And that's good for anything that we can ship to you. So we don't use that on, the coupon code doesn't work on gift certificates or subscriptions or software, but it is good on stuff. So go check out some of the stuff we've got. You know I'm a big fan of these thin little USB-C cables. These are the ones I used in the LED dance shoes. These are great. Now we have all sorts of different sizes of them and orientations. Same, opposite. Those are really great for small USB-C powered projects. And actually those are power and data, so it's not just power. But anyway you slice it, you can get yourself 10% off with the coupon code FRITTER today. So write that down, remember that, and type that in later so that you can save some money. Speaking of saving money, I've got a show on Tuesdays, which is the JP's Product Pick of the Week show. This is what it looked like this week. On the show, I like to pick a new thing, sometimes an old thing, this week a pretty new thing. Give you a big, huge discount on it. That was 50% off this week for that product pick. We stash 100 of them, so we have a minimum of 100 of them ready to go when the show begins that you can hop on and buy during the course of the show for the big discount. And here is a little recap, a little 1-minute recap of this week's product pick. ST Spin 220 stepper motor driver breakout board. It's got the terminal block on there, which is good for bipolar stepper motors. So it's got 4 wires there to control the motor. Voltage incoming for the motor on the terminal block. 1.8 volt motors up to 10 volt motors. So what you see here, I've got my ST Spin 220. And on the right side here, right to left, I've got the stepper motor, little NEMA 8 stepper motor wires plugged in. And then I have coming in this LiPo here directly. So that's going to use anywhere from 4.2 to down to 3.7 volts on that LiPo, depending on charge. I'm using power and ground from a little QT Py RP2040. The pins that I'm using here are direction, step, and MS1, MS2, so that we're able to control the step size as well as the enable and the reset. It is the ST Spin 220 stepper motor driver breakout board. Yep, that's right. That's what it was. Wow, that was loud in your replay, Thin Man says. Huh. Wonder why. Sorry about that. Okay, I won't check it right now, but I will. Oh, I'm quiet on the mic, huh? Oh, why? Let me check a couple settings real quick. See if that audio got bumped down. No, it's at full gain there. Does this test? That doesn't change that. Test. That doesn't change that. All right, I'm going to bring this level up just a little. And you might want to adjust your volume because, yeah, my gain was pretty low. I'm going to try to bring, hopefully no crackling and clipping, but I'm going to bring me back up. Okay, yeah, I'm about -6 dB there, so hopefully you can hear me. Can you hear me? Starman cannot hear me. All right, I'll let that settle and simmer there for a moment and see. Oh yeah, something is funny. I'm seeing that preview is getting quieted. Now I'm loud compared to my current volume. Sounds better to you. Okay, thanks, John Notch. That's better. All right. Whew. Yeah, it should be a little higher. I'm going to bring it up even more. Yeah, so that's interesting. It looks like it's clipping on my audio interface. I don't trust this audio interface, though. You know what I don't trust? Speaking of which, so I'm going to try to keep an eye on if anyone notices I disappear. I don't know if I've ever mentioned this. My mic pack that I use here, see the battery? It's impossible to show. It's very reflective. There's a battery indicator right there. And it shows either 3, 2, or 1 little battery chunks. Well, so it's a third. It could be 33.333% full or very close to nothing, and it does not tell you. So that is one reason. I don't want to waste batteries and change them out every time the thing gets to a third, but it's tempting. No one wants their batteries going out. All right, well, hey, thanks again. The ongoing, many years long journey of me trying to make my audio work well. It's a lifelong journey, really. Okay, so let's get on with it. You know what? I'm glad I got the audio worked out, because that'll help us out on this CircuitPython Parsec. Okay, for the CircuitPython Parsec today, in the continuing saga of this Nintendo controller on Feather with memory display, I want to talk about firing projectiles. So last time we started moving an object around, it was a circle last time. Now I've turned it into a little triangle. And let me, I'm gonna make this part of the screen a bit bigger so that you can see that better. And I'm gonna fix that focus. Ooh, there we go. It's a sharp looking, sharp brand and sharp looking display. It might as well be in focus. I'll try to fix that. There we go. Okay, so now on top of having a Nintendo Classic controller, which is an I2C controller using our little I2C Stemma QT breakout, and moving an object's XY using the D-pad, I want to be able to fire projectiles as if we are playing a little game here. So the way that I'm doing this, we've got all of the same imports as before pretty much. I'm importing the time board for pin definitions, display I/O, frame buffer I/O, vector I/O so I can draw a fast little shape, Wii Classic library from the community so that we can use this, this Wii Classic controller, the display shapes rectangle to make the white background, and the sharp display library. We're releasing the display with display I/O, and then I'm establishing this controller, or rather this display on the SPI bus. Once that's set up, we initialize I2C so we can use the controller with this great Wii Classic controller library, set up the main screen group, set up that white background, define some colors, black and white, it's a monochrome display. And I'm setting up the ship now as a triangle, so I'm setting up a size which it's going to derive the vertex positions from, and I'm placing it halfway on the screen but down at the bottom when we start. So display height minus the ship size lifts it up above the horizon there. And I'm setting my move steps to be 18 so that it's pretty fast. It stutters a little bit, but it's pretty fast. We set up a palette for that so we can draw it, and then this is the creation of the actual ship here. Then I'm creating this projectile, which is that little circle that you see there. So I'm setting up a radius for that and the speed as variables, setting up a black and white palette for that, setting initial state of projectile to be none. And this way, I'm going to do it Space Invaders style, where I can't shoot a second projectile while the first one is going. So Space Invaders style, those are the rules. You have to wait for that projectile to hit something or get off the screen before it disappears. So initially we're saying there is no projectile. And we'll be checking that to decide when to get rid of one projectile and allow another one to be added to the screen. The Y position is initially set to 0, and then this is state tracking for the button. And then in the main loop, like before, I'm checking control pad, D-pad up, down, left, and right to see how we move the ship based on that move step interval. And we're also now, before I was letting it fly off the screen, but now I'm constraining that so that if we move too far to the left, we just hold it at the left, too far to the right, hold it at the right. So that's just based on the 400 by 240 screen dimensions. And then to, again, avoid stair-stepping, we set both X and Y simultaneously. So those will move in a diagonal line and not little stair steps. Now this is where we get the projectile added to this. So First thing we do is check to see if the button has gotten pressed. If it's been pressed, the projectile is none, meaning there isn't one on the screen, then we can go ahead and proceed. Only fire a projectile if none exists. Then we create the new projectile, which is a vector IO circle using the pixel shader, color index 0, so that's black, the radius of 4 that I had set before, and then the ship's XY position is where we fire it from. The projectile gets added to the display IO group, the screen group it's appended, and then the projectile Y value is set to wherever we got launched from so that we can then base subsequent moves from that. Ship doesn't have to move for the projectile to move. And then we check to see if the projectile exists, then we're going to move it up on Y by setting this variable. Projectile Y equals projectile speed. So the screen 0 is at the top and 400 is at the bottom. So we're going to subtract that move speed, I think I set to 20, from each step, each tick of the clock of the program. And then if it goes off screen, we want to get rid of it. So if that projectile Y variable is less than the radius of the square of the projectile, so basically 4 pixels off the screen, that's when we know we can hide it. We will remove it by doing screen group remove, so that takes it out of that screen group. And we also clear out the reference to it so that we're allowed to make a new one. And then the whole game ticks along, refreshes. And you can see over in my, if I open up the REPL a little more, you can see I'm just, for debugging purposes, setting when the projectile gets made, so projectile fired. I'm setting its position on the screen. I said 400 before, rather. It's 240 rather, 240 high. So this is going to subtract as it gets past the top, the origin on Y, and then it gets removed. And so that is how we can fire a single projectile inside of our game demo inside of CircuitPython, and that is your CircuitPython Parsec. Oh, and darn it, so my mic is clipping now a little bit. Sorry. Thanks. I wish I had noticed that. Yee! All right. Well, hopefully that's not too bad on the 1 minute or the CircuitPython Parsec clip that I'll make later. Hope I don't have to re-record it, but we'll see. Clipping a bit. You're not screaming in pain. I don't see blood, so hopefully that's okay. Hey, Toddbot. Toddbot just joined us. Asks if this is the live spaceship chat channel. Yes, that's where you're at. That's the chat. All right, let's see. Next up, since Carr over in the YouTube had asked, had expressed interest in Arduino, and for other reasons, but I'd like to do a little bit of a recap of my last project, which was this Learn Guide here. It just came out yesterday, I think we published it. And this is the Pico Bluetooth keyboard bridge. If you've been watching the show, you've been seeing me develop this over the last few weeks and work on that code in Arduino. And that is now up and out there and ready. So first of all, I'll say that my camera lens was smudged, so I accidentally got a really lovely lens flare right here on this LED. That almost looks like I added a lens flare in Photoshop, but that was the smudged lens gave us a nice lens flare. I cleaned it and took another photo, and I don't like that other photo at all. So there's no shenanigans there. That's the real photo of that lens flare. So that's using the Pico Plus 2W from Pimoroni, which I really like, especially because it has the reset and boot buttons on there. It's easy to work with. But this project works with the Pico W and the Pico 2W, as well as this variant on the Pico 2W. You can see a little setup using, that's a Bluetooth Classic keyboard. If you're not familiar with this project, I've got a Pico W or 2W, which can deal with both Bluetooth Classic and BLE, which are basically different protocols from each other. A lot of keyboards are Bluetooth Classic. Some are BLE, and sometimes you have no idea which. So this project, the code in its basic form, will try to connect to a Bluetooth keyboard, and then if it doesn't after a little bit, it will try for a BLE keyboard, and it'll keep looping that. So it's one way that I found to make it a little easier to just connect up to unknown devices, since I do have a lot of keyboards. Found out the Apple Magic keyboards. Do I have one here? Is this a wired one? Yeah, I think I took those. Yeah, okay, here you go. The one I brought inside was Bluetooth Classic. I don't know about this one. This is one of these early ones that they made, I think, for some of the iMacs. Maybe they worked, I think they worked on iPads. It takes a couple of AA batteries in that cool tube there. So some of these are Bluetooth, some of these are BLE. This project will work with both. I did a little demo video, so you can see that, doing the different pairing attempts with BLE and Classic. Made a little variation on a case from the Ruiz brothers to just make it a little more compact for this project. And I do link to we do have a couple of these nice short, what are these, 6-inch long USB A to micro B and USB A to C. Those are pretty good bet for plugging in a lot of your stuff that's the host, where the HID things will be happening, including Fruit Jam, which I don't have working yet, by the way. I'll post an addendum to this when I figure that out, or it may just be a CircuitPython 10 beta thing. But there you can see USB A host. A lot of our code for Fruit Jam, Metro RP2350, will allow you to plug a keyboard in. We want to get this working where we can use wireless keyboards and our little Pico dongle. So that's part of the genesis of this project. One of the nice things is that you can grab the UF2 file out of your user cache. Thanks to ToddBot for pointing me in the right direction for this. On the Pico 2W, you can compile and upload, and then grab that UF2 file. So I've put them here. So if you just put a Pico W or 2W in a bootloader mode, you can drag, drop one of those two UF2 files on there. The instructions here show you to put that into bootloader mode. And then I do show you, here's the Arduino code. So you can check this out, Car, if you're interested in checking out the Bluetooth code. I've got the code here, as well as an explainer that'll tell you what the sections of the code are doing. Then if you want to, if someone's new to Arduino, they can check out this Arduino on Pico section here. This will get you set up with the Philhauer core, which is what you need to use RP2040 in Arduino IDE. Connect up your board, upload a sketch. So if you want to alter the sketch, I do have, if you look at the top of the code here, here's some user config stuff. So debug mode will just give you verbose messages in a REPL if you're connected up to it. The blink modes, if you get tired of seeing it flashing while you're typing, right now it flashes every time you hit a key. You can flip that to false. And then scan mode, you can set to either just, if you know you only want to use this with a Bluetooth Classic or a BLE, you can set the scan mode to one or the other, or you can set it to that default of both, and then it'll cycle through trying to find them. So those are some user options that you may want to change. You could also extend this code further and say, hey, you know what, I want to give myself a little button press I can do upon launch to decide which of these modes to be in. You could add an I2C device with some buttons on it to make it plug and play still. Your choice on any of that stuff. But those are some reasons why you might customize the Arduino code and then upload it with the IDE versus just grabbing these UF2 files to drag and drop onto your board. And then I have here's the use setup, so it shows you to plug it into your computer. That's going to be the target. In the case of these examples, I was using a little Raspberry Pi. The Pico LED codes, it'll blink slowly while it's trying to scan for a device. It's kind of the same speed that my Bluetooth Classic keyboard was blinking at, so they're kind of looking for each other. It blinks rapidly when one gets found, and then as soon as you start typing, we go into this steady LED and blinking as you're typing mode. You can press the boot button on the Pico, which is kind of cool. You can actually use that as a user button in Arduino after you've started a program, once it's running, it can switch over from some bootloader mode into just user button mode. And when you hit that, it'll then start the rescan process. So if you dropped the board, lost power, wanted to switch to a different keyboard, you can try to hit boot. That seems to sometimes not work as well as just resetting the board. So if you have a Pico Plus from Pimeroni with the reset button, hit it. If you have a Raspberry Pi branded one, power cycle it is the reset. So there you go. And that here's a little link to the case files that I made, just adapting the Cerise Brothers one. If you want to buy it's only $2.95. If you want to buy pre-made case made in SLS nylon powder, I think is what that one's made from. It does have those little mounting tabs, so you can put it on a belt or a watch or a backpack or whatever you want to strap it to. But it is pre-made for you there. So that's the case. I just took that and shaved off in Rhino. I shaved off the tabs there. Let's see. What else? I think that's that for that project. And now let's move on to this. Actually, let me check the chat for a moment, and then we'll move on to some Apple stuff. Let's see. No complaints about audio, which is good. Phew. Let's see. Yeah, J.J. Abrams lens flare. That's what I was doing. Todd says one of the coolest things about RP2 series of chips, which is the 2350 and the RP2040, is being able to get an entire image of the flash as a UF2 file using Pico tool. Makes it super easy to give to someone else. Yeah, so you can use Pico tool, search around. That's from Raspberry Pi. They have a little command line tool you can use to grab the UF2 file. And if you search around, maybe Todd can put a link to this. I'll add a little box to this guide actually to tell you where to look. But when you compile it for the right board that you're about to push it to, a UF2 file is saved in a cache directory. It's like user, library, Arduino, cache, and then the name of the project or something like that. You can go and grab it out of there, and it iterates those. I don't know if it ever cleans that up, honestly, but it iterates those so you can go back and find them inside of that directory, which is pretty helpful. And it, I think, includes maybe the name of the board in the folder or the file, so you can, in this case, I compiled it for the W and for the 2W, and then was able to grab those. Pimeroni Pico plus 2W uses the same exact file. There's no difference compiling in Arduino. You'll use the same one. Cool. All right. Last thing I'll say about this, hidden feature in, I think, Bluetooth mode. I do have a little bit of code in there for mouse. I can't remember if it's in BLE mode as well. But if you do connect up a Bluetooth mouse, you should be able to send those over HID as well. So I don't have it set up to do both, and I wanted to just focus on the keyboard, but the code is in there, so if you pick through, you will see some references to mouse X, mouse Y, and mouse button. At least one of the mouse buttons is coming over that message. So there you have it. Okay, so next up, let's talk about this right here, this Apple II Plus, which you can't see the logo on because I got all kinds of monitors and things on there. Let me look. Okay, we're looking at the back of it there. So I'm going to head over. Let me head over to the workbench here, and we'll talk about this Apple II Plus. I am just going to pull up the chat so I can see if we have any issues. So I'm going to get this monitor out of the way a little bit so you can see right there. Apple II Plus, the 2 reads well. You can see Apple II Plus right there. This is a computer that a friend of a friend got in touch with me and said, hey, I have my childhood Apple II Plus computer, and it was working, and I was playing Zork, and then it suddenly stopped working, and I'm wondering if you can fix it. So I just got this like 2 days ago, and have just started taking a look at it, trying to diagnose what's going on. So I wanted to get inside of here, have a look with you. Oops. Watch this power here. And see if we can at least get it to boot, and then figure out where to go from here. So I've got a couple of monitors plugged in just so I could see stuff and show you stuff at the same time when we get this up and running. But for now, I'm going to pull some things apart here. I think you can see that pretty well. Maybe I'll turn, I've got one other light here I'm going to point at. There we go. So yeah, I've got a little bit of a mess of video cables there for that. So I did not have a 2 Plus. I had a 2E growing up, but this one's a 2 Plus, which came right before it. They're very similar in a lot of regards. There were just some improvements in quality of life things that happened with the move to the 2E. But it's definitely bringing back some memories, having a look at it. So first thing I'm going to do, I'm going to unplug it from power. And if you're not familiar with these, they have a sort of plastic version of Velcro built into the top of the lid here that you just snap up, and then you can take that off. So these little Velcro-y tabs there are what hold the thing closed. And let's get a closer look in here. That focus is pretty good. So what you see is what you get with this. We've got a disk drive, disk 2 controller here. I'm going to go ahead and remove that from there. That's what partially powers the disk drives, and you can plug two of them into here, disk 1, disk 2. And when I got it, there was a modem plugged in, which I've removed. So this is a 300 baud Hayes modem. So that was in another expansion slot with the phone connector just mounted onto one of the slots on the back there. So keep that out of there. And I figured before I even try to turn the thing on, I'll just remove everything I can to get it down to as simple of a setup as possible. There was also a paddle controller, little set of 2-player game paddle controllers, and this is interestingly, you can see there's an empty socket here. That's where this controller plugs in into a little DIN socket, if you can see there. So that was actually physically connected here but not plugged in, so I'm leaving that, and I'm actually unsure. I think this 1 refers to pin 1, so I think that's the orientation it goes in, but I want to look that up before I plug that in wrong. And then there is a RAM card expansion card in here. This is Quentin Research 16K RAM card. And then, while I think you need to be connected to load to test this power supply for real, I did unplug it from the board, and on the, I don't think you'll be able to see it, but on this end of the power supply, there's a little diagram of the pinout on here. So we have 2 ground common pins, and then we have a +5 volt at 2.5 amps. We have a 12 volt at 1.5. We have a -12 at 0.25, and we have a -5 at 0.25. I took these and checked them out on the multimeter. I won't do that now, but just to see, yeah, okay, it does give me that. So the power supply at least is on, maybe not under load, but it is supplying some power. And then with all of the peripherals disconnected, I went ahead and let me plug this back in. Hopefully I get this right. Let's see if this, think that monitor is on right there. So you might see that here. It's not going to show much. And then I'll turn on this little portable monitor here that has a composite in. So this is all composite video coming in from here. I'll go ahead and give the power supply power, turn it on, and we get boop, beep. That's good. You can see down here there is a power light on the front. I may have turned this monitor off. Did that come on? Let me check. This one might have switched sources or just come loose. All right, let's look at see. Is this showing us anything? No. Oh, there we go. I just have loose cables. There we are. Okay, this one should phase in. Yeah, okay. I just have a loose video connector there. These are going through BNC couplers. Okay. So there you can see Apple II. So that booted. It's not an ideal monitor for it, but it does stuff. So let me... I think this one will be more visible than this CRT over here. Oh, not with that glare on it. Okay, let me try to... I'll put the cover on it. I don't want to cause a disaster. So this is already improvement from how it was working when I was told, hey, I think this thing is dead. Maybe it's the power supply, which is a pretty common cause for this machine to not start. So there you go. I remember very little, but this is AppleSoft Basic is what this has on it, what it starts up in. So we can type in a basic program, real simple basic program, 10 print, hello Adafruit people. Quote is up here. Return, let's do 20. There is no backspace. Go to 10. We can list our little program. We can run it. Whew. So it's got AppleSoft Basic on it. Fun fact, I only realized because I was looking some of this stuff up online. I never realized AppleSoft Basic is called that because it was written by Microsoft. So it's a collaboration. There was Integer Basic that Wozniak wrote, and then they wanted a floating point Basic, which Microsoft had, and so they called it AppleSoft, which is wild. So Control C will get it out. Break. You can ring the bell. G. Control G. You can reset. You can home. And that's about as far as I'll take that. But the key thing here is that, okay, it does stuff, it works. I'm going to tempt fate a little bit here. So let me turn it off. One thing I'll say, I am noticing a little bit of a sweet smell, which I think is often a capacitor heading to death on the power supply thing. So I'm not going to run this too much. I don't think I'll do disk stuff, so I don't want to draw bigger currents from it. But I will, so this is cooking show style. A little of this is stuff that I did already. If you can, let me zoom out enough so you can see the power on there. And I'm going to take this RAM card. It's from Quentin Research, who I've never heard of. 16K RAM. So I believe this is a 48K machine. These are the RAM chips right here. And you can see we've got another one of these white sockets that it was cool. They color-coded those. That was one that was typically, if you were going to use a language card that had a language built onto it to boot into or to switch to, it would have a little cable running to that first RAM slot there, which allowed it to access this. I guess it doesn't need that for this use case of 16K of RAM. And the guy who's given me this to fix did have this running as configured, as far as I know. But if I try to start this right now with that card in, nothing. So I'm going to turn that off. I'm going to pull this, start it up, boop, it starts. So I suspect we just got some bad RAM on here. I looked at it under a microscope. I don't see any shorts. I don't see any bad solder joints, any cold solder joints. Everything looks good. None of these caps are like legs touching metal or anything like that. So I suspect it just went bad, especially because this guy said he was playing Zork and then it wouldn't start. So I think maybe some RAM met its demise. And so this 16K of RAM, I believe, is no longer. So since I am smelling this smell, yeah, that's a good question. Ion U2, Darth Paul says, can you look at it with a thermal image, see a hot chip? That would be interesting. I do have a little thermal imager, one of our feather wings actually, that I could maybe use on that. Just checking here, we're not getting like a ton of heat off of the motherboard, power supply. Like I don't feel anything dangerous. I don't smell anything other than sometimes that little sweet smell off of there. Something I mentioned about this that's kind of neat. I mentioned this on Show and Tell last night. Let me turn this back off. I'll unplug power here. I'll unplug video. In the side here, we can take a better look at it than we did last night, is a Super Mod 2 channel 32 to 34 TV interface unit, black and white or color, M&R Enterprises, Sunnyvale, California. So this is a, you know, the output that comes from Apple on the back of this. You can see it down there. That is composite video, and then this is audio. Cassette audio out and in. So if you're getting data off of a cassette, you'd use those. But this is the video out, which is great for a real monitor. But actually, with the Apple, until the Apple IIe, there was no Apple branded monitor, so you were just using kind of whatever monitor you had. And a lot of TVs at the time did not have a composite in, so you'd use the RF modulator. So that's what this is. This would give you a video modulation out, and then you'd use a little RF modulator on your TV. Kind of like how you'd pick channel 3 with your Nintendo or something like that. This was on channel 32, 33, 34. And what I read about this is that Apple couldn't get permission to include this from the FCC, so they contacted someone they knew who started up a little business selling this. So I don't know if they were installed maybe at the dealer. It just plugs onto the board right here, and I'm guessing it's grabbing, looks like, I don't think that's grabbing RGB. Yeah, I think that's still maybe still composite. It's 4 wires though. I'd be curious what that signal is that goes to this modulator. Maybe it's a pure RGB sync signal, I'm not sure. But it does get composite out of the back and RF off the side there. So some neat little facts about this thing. So I think my next step is to pull this. I'll do that right now, in fact. Turn off these monitors. I'm going to do this in a slightly goofy way so you can see. So these 4 screws on the bottom hold the power supply in place. And what I'll do is take it apart, check some of the filter caps and other, just visually look for any fat caps that want to explode and die. I did check Adrian's Digital Basement, which is an amazing YouTube channel for retro computer repair and other things like that. And he does do at least one video on a reconstruction. Whoops, there's that screwdriver. Get a different screwdriver. How's this one? This will work. And so checking his video, he's got a couple of suggestions on filter caps to replace and maybe another cap or two. So either I'll do that rebuild, which might be all it needs. As he was saying, that a lot of the parts are really nice quality, despite their age. They hold up well. So it might not require a replacement. My friend said that he does have a replacement power supply. Must come off another machine. But there's also a company who makes really nice modern kits to rebuild. So for like $80 to $100, you can get a very modernized power supply to replace the board and components in here, but still keep this enclosure and connectors and such. So let's put this back here. I'm going to set down a mat on there, and let me get that screwdriver that just dove off the bench. Or not. I don't know where that went. Sorry. I'll use this one. So I may, you know what, I think I won't do this here because I think I'm going to need to drill out these rivets, and I don't have the stuff prepped for that. Yeah, there's 2 rivets on each side that I think will need to get filed or drilled besides these screws. Yeah, I think that's riveted right into that tab there. We can try, but I suspect I'll do this offline and then update you on progress. Ooh, someone on the chat, John Notch, found the, thanks for finding it, found the Supermod 2 documentation, and it is ground, modulation in, NC, and V+, are the 4 wires leading to that. Oh, maybe I'm okay. Yeah, okay, maybe we're good. Yeah, I'm smelling that sweet smell. It reminds me a little bit about the smell of certain fireworks, like snakes. I don't know if you've ever used potassium permanganate and glycerin to make little fiery smoke bomb things. It reminds me of that smell. Will it open? Ah, bottom's opening. Yeah. Yeah, okay. And we're off. No swollen caps. Woo, yeah, definitely get that smell. It could also be varnish on the transformer in there. Yeah, okay, I'll leave it here because I don't want to dig around on the show right now. There's a bunch of like enamel to snap on these screws to pull this out. So this I'll do offline, but there's a little look inside the power supply. And let me show, I'll head over here. I'll show you this nice looking replacement. Yeah, no dead rodents either. It's amazingly clean. I think this guy who brought it over to me had it like in the box at his parents' place. So it's a really nice clean shape. Let's see. Let me find these guys. Reactive Micro. So Reactive Micro, Apple II Plus series, and so we got a few different things. There's, I think, some parts kits. There might be parts kits for rebuilding your supply up here at the top. But this is the kit here to just change your guts out to a much more modern supply, which 2 Plus 2E, $80. And you get to put together this nice looking supply, which should give it many, many years of happy use. So I think that's what the guy I was talking to wants on his machine here. Is just, let's just go for something new. John Nudge says Supermod has a Wikipedia page, manual page from sources listed. That's great. Yeah, let me open that. Let's go to. Thanks for finding this, John. Yes, so this is the Supermod. Wideband, black and white, or color compatible interface system intended to convert the home TV to a full video display for home computers. I will say I hooked up just the composite to a color, that big Sony sitting there on that bench. And there's no comparison between that and this black and white monitor. This was like a security monitor. Is so razor sharp because you don't have like RG and B guns all converging and trying to make white. Just the black and white looks so good on these. Which is why these monochrome monitors were so popular back then. And these little small 9-inch ones are great because they fit stack of hard drives next to them nicely. I've been watching some YouTube videos and noticed people pointing that out, like, oh yeah, it made sense. These little square PVM style monitors work great because you can stack the whole unit. So yeah, there you go. Ground modulation input not connected. The red is not connected, and then orange 5 to 12 volts. Yeah, so it's the same signal that's going out to the composite out, just coming into here, and then get RF modulated. Super cool. Were you expecting dried apple ring slices? Yeah, it could have been some little delicious cinnamon apple cider donuts. I don't know. It had that smell. Yeah, no puffy caps, no rodents. Okay. Speaking of, yeah, Zork, and you were eaten by a Gru. I did get, I think once I get the power supply sorted out, I'll try stuff with the disk. But Zork 1, a copy of Zork 1 here. Zorro from Datasoft. And then the game in the disk was some kind of Microsoft branded Olympic Decathlon for Apple II. So one thing I'll do is, since we don't have the 16K, I think all of these will run on the 48K, but I do want to maybe make a ProDOS disk if I can cobble together the right things, or there are ways to write off of your audio interface card to the machine as if it's got the cassette on it, and do some diagnostics, some RAM diagnostics. So that's another thing I'll be looking around for, is just to say, okay, of the RAM that's in there, is that good? Because I think there's 3 banks in there, and one bad chip will take out the whole bank. So some of this stuff won't run if it's got problems. But I suspect it was this 16K card that was the issue. So we might be in good shape. All right. I think that is going to do it. Let me know if you got other thoughts. Dave says, careful with those high voltage caps. Definitely will be. I may go with that PSU route with my computer when I cycle back to it. It says Beatograph up to Hagen. Yeah, you know, I do not have a old Apple. Mine is long gone. My Apple IIe I grew up with is long gone. I don't have, other than a Commodore 64, the little TRS-80 portable, and then this VT102. I don't have any classic, I don't have any vintage computers, so it's fun to get my hands on this. I don't know that I want to start collecting them. I'm out of space, so it's fun to maybe get in there, play with it, and then get it out. Yes, E. Grover points out caps can leak dielectric from the leaded end without bulging. Yeah, so we could be dealing with leakage that went out the bottom and didn't puff out the cap. The board looks nice and clean though. That's a good sign. I see zero leakage, which I'm happy about. But I suspect Josh is onto something with saying, let's just swap for this modern supply. Why not? It takes 15 minutes with basic tools. All right, before I go, I will remind you, Fritter. I didn't find any Apple fritters in there, but Fritter, that is going to get you 10% off in the shop today. So head on over to Adafruit.com, look for some neat stuff, throw it in your cart, and get 10% off by typing Fritter into the coupon code. Let's see. What else have we got going on? There may be Desk of Lady Ada videos over the weekend. Who knows? I don't know. Go look. We'll be back on Tuesday with a product pick of the week. Wednesday, I'm not sure if there's 3D Hangouts. They might be off for this coming week. And then I'll be hosting Show and Tell next Wednesday. And there should be a Ask an Engineer after that. We'll see. So thank you, everyone, so much for stopping by. And I'll see you soon. For Adafruit Industries, I'm John Park, and this has been John Park's Workshop. Bye-bye.
Thank you.